Okay, sorry for the delay. All right, this is the IPFS all hands call for July 17th, 2017. And the agenda is up in GitHub. So, and Hector is the note taker, and I'm Matt Zumwalt from Protocol Labs. We have actually a lot of new people, and not a lot of agenda items. Should we do a roll call? Yeah,
let's do it.
Yeah.
Can I make a suggestion?
Yeah.
That in addition to the roll call, we mention like the one thing that's keeping us up at night or keeping us really interested or really capturing our interest about IPFS right now.
All right. Wow, we're on 2 pages, even with the really big grid view.
Yay, 21 people.
All right, so yeah, what was Michelle, actually, if you go first, then you can model how we can,
Wow.
And then let's go, and then we'll go west to east instead of east to west. We're gonna switch it all up.
All right, hoisted by my own petard. My name is Michelle Lee. I'm part of the Protocol Labs team focusing on product across a few of our different projects. With regard to IPFS, the thing that is capturing my attention right now is how we move from a world where we have a lot of really interesting and fantastic pilot use cases to getting deeper into the stack of organizations and becoming part of more organizations' critical infrastructure. And accordingly, what features or capabilities we would need to build to make that attractive and possible.
Cool. Now, west coast of the U.S., north to south. So is there anyone in like Seattle or Oregon or anything?
I'm in Portland.
Yeah, I'm in Seattle. I think I out north you for a moment. So Kumav is here. So I work on Ethereum stuff, specifically MetaMask, which is an account manager under Consensus. And what has been keeping me up is trying to build a light client off of an Ethereum light client off of IPFS and the P2P, and I'll be demoing that later today.
Kyle?
Can you hear me?
Yep.
I always have to ask with Linux. I'm Kyle. IPFS. Well, this is interesting. I actually did an analysis of bandwidth rates the other day for a talk and Amazon, like all the big cloud providers, they all charge the same rates for bandwidth that they were charging in 2007 and 8. So I thought that was kind of interesting. They're exactly 10 years behind on like the current price of bandwidth from like IP transit carriers and stuff. You know, obviously IPFS is a great way to not have to pay bandwidth rates like that. So that's kind of nice.
Cool. Further down the west coast of the U.S., I know David's in Palo Alto.
Yeah, so I guess like it's my turn. So hi everyone, I'm David, work for Protocol Labs and mostly focused on just IPFS and only peer-to-peer. And there are many things that are keeping me awake at night. But I guess like picking one, I've been very excited to push a bunch of tutorials and demos using with peer-to-peer and just IPFS, enabling more developers to like get into the distributed world and like shipping more apps. You might have seen a lot of tweets recently. Really appreciate all the feedback and support. And yeah, really excited about enabling more people.
All right, Mountain Time in the U.S. Is that David? Definitely David.
Yeah. Oh. You can go, Herman.
Chile is in the same time zone as the East Coast of America.
Oh, as the East Coast.
Sí, yeah, yes. Okay, I'm Herman. I work on Ethereum stuff. I'm collaborating with Kumavis on deploying the light client on top of IPFS. And what keeps me awake is understanding how to deploy everything in a decentralized network. and to try to do that first with Ethereum, then with Wikipedia, WikiLeaks, then the word. Hmm?
I'm David. I'm in Colorado, so I think I'm next. I go to Colorado School of Mines doing my master's research on BitSwap and incentives and things like that, and working on IPFS cluster also. And I guess the main thing I've been thinking about a lot is implementing, incentive type mechanisms that don't involve currencies in such this decentralized system, and not like messing anything up in that process of actually analyzing the real world situation versus like the theoretical math side of it.
All right. Jay, aren't you in the same time zone?
Well, Arizona's kind of a rebel. We don't follow daylight savings time, so I'll consider it mountain time. Anyway, my name's Jay Carpenter, and what keeps me up at night is just digesting all of this. It's just amazing. And we're working on a variety of things with a group here in Phoenix, and we're working with JS-IPFS. We're working on some interesting ways to maybe incorporate the Internet of Things with the IPFS construct and protocol and so forth. And we're also working on some ways to possibly bridge and harmonize the old with the new in terms of naming and addressing, numbering, and identity. So it's like a fire hose right now. So I think Jason's on the call as well. Jason, you want to introduce yourself?
Yeah, I'll go next. I'm here in Arizona as well. I'm working with Jay on a few of these projects. I'm looking into a lot of different use cases, trying to implement IPFS into a few different use cases using WebRTC, Web3.js, and some other things.
All right. Anyone else in that vertical in Mexico, Central America? Any others? Or in the Midwest of the U.S.? Anyone?
Hi, I'm Roberto from Brazil. Just listening and trying to absorb all this.
Great. Welcome. Is there anything in particular that you've been especially working on or interested in or excited about or worried about?
I'm just using IPFS for some time now. Just trying to do things, try to use it just like another protocols of distributed networking. Try to understand and to hopefully improve it.
Great. Welcome. Anyone else in sort of Midwest-ish areas? All right. Well then, that gets towards me, and anyone in like your sort of Boston, New York strip, Canada, Newfoundland? Okay. So I'm north of Michelle by 5 minutes bike ride. So I'm Nat Zumwalt with Protocol Labs. What is keeping me up is that we will be soft launching a website for datatogether.org sometime this week. And I'm excited about it, but it also has not gotten though it's gotten a lot of attention, it's not gotten as much attention as it deserves from me, because it's exciting stuff of trying to develop a model of how do we think and talk about organizations using the decentralized web to store stuff and manage stuff, and allowing communities to use that infrastructure. And another thing that's not keeping me awake, but I've been thinking about a lot, is that I didn't realize that there's been this whole rebranding of cloud services as being serverless. And so our use of the term serverless is getting confused by people who are actually just selling cloud services. And I'm not quite sure how I want to work with that, but it's annoying. So to be continued. Oh, and Michelle already went. So then anyone else on this sort of East Coast strip? All right, let's hop the pond to, oh yeah, Matt and Sawood, You're on.
Hi, I'll go first. I'm Matt Kelly. I'm a PhD student at Old Dominion University. I am currently working on interplanetary wayback, which Suud and I developed, and we demoed at IIPC WAC in June, and we're kind of evolving that to be a little more production worthy and figure out the testing and that kind of stuff. So we'll be demoing that today as well.
Cool. Suud?
Hi, I'm Saud Alam. I'm also from Old Dominion University, sitting next to Matt right now, and always in the office. So yeah, we last year in March, we were in a hackathon where we were running out of ideas what to work on, and then this IPFS thing was like hitting in my head for a long time. So I thought, hey, let's bring it to the archiving community, and we implemented an archival replay system there using IPFS, and we call it IP Wayback. So yeah, we'll be doing that today. But I'm trying to graduate. There are a lot of things that are pulling me towards IPFS. I'm trying to stay away from it as much as I can, but that's difficult, you know.
Cool. Thanks for working on that. Anyone else in North America or Central America or South America that we've missed? Okay, well then let's go to over into Europe, and I'll let you guys sort out the ordering. There's no Devix. He's not in Portugal.
I think David already went. No?
Yeah.
Okay, so I'm next. I usually live in Barcelona. Today I'm in Alicante, so a bit further west, I guess. My name is Victor. I work at Protocol Labs as well, mostly with JavaScript things, some things with the infrastructure and other stuff. I think the same as many others, I have a lot of things that keep me awake. But most importantly, the applications that you are able to build on top of IPFS and be able to have offline apps that works together with different kind of networks, and you don't have to be connected to the backbone itself. So basically removing ourselves from this centralized lock that everything is tied to right now.
Who's next? We don't have Friedel.
Okay, I'll go next, although let's go through the Mediterranean. Let's do south. So I'm Vizo. I'm in Thessaloniki, Greece, and I'm contracting for Protocol Labs. And well, the things that keep me at night are network protocols. So how do we defeat network address translators? So I'm working on Relay now. And we're also things like WhatsApp, and these are my interests at this point. Right? Who's next?
Should we do Berlin?
Yeah, let's do Berlin.
Okay, so I'm Hector with Protocol Labs. I live in West Berlin, and what keeps me up? I work mostly on IPFS cluster, and I haven't been able to put much time into it lately. But I have good news, is that a new release will be coming very soon. And it has a couple of features, and it's coming really close to a point where it is mature enough that you can just use it in your data center, or just to keep a couple of boxes in sync with a pin set. So that's very nice. And yeah, that's basically it from my side.
Okay, nice.
Awesome. I'm excited for that. My name's Lars. I live in West Berlin, and I've recently had my second anniversary of contributing to IPFS. And what's keeping me up at night is similar to how IPFS is starting to eat up the web one data set at a time. I want to see the peer-to-peer eat up the backbone of the internet, one network at a time. And so that's what I'm thinking about a lot. And there's going to be some exciting work on that in the second half of the year.
All right. Anyone else left who wants to introduce themselves?
Probably me. So I'm Lucas. I am currently contracted for Protocol Labs and yeah, working on data store and other stuff that should make Go IPFS a bit faster. And yeah, that's probably it.
Anyone else want to go? Or you don't have to if you don't want to. Okay, nobody's speaking up. Lars, thanks for reminding me. I think today is exactly my 1-year anniversary of starting to contribute to the IPFS project.
Yep, I think so too. Good to have you.
Yeah. All right, so diving into the massive agenda, which is no agenda items. If anyone has any agenda items, speak or hold your peace for another week.
It looks like we have a Steven who wants to introduce themselves, but their mic is not working.
Oh, Steven's Stevonian. All right. Well, hi, Steven. Welcome. Steven's doing great work. You've probably seen some of his comments on Discourse lately. And
then I have the Ethereum IPFS demo.
yeah, we have 2 exciting demos, and we have plenty of time for both. So let's say go for it. 10 minutes, and we can even have some time for discussion, even if it runs long. And then we have the Interplanetary Wayback also being presented after you. So 2 exciting demos. Great. Take it away, Columbus.
Yeah. So sharing screen usually melts my computer, so we'll see how far we can get. Can you see my screen?
Yes.
All good.
Cool. So this is just a little sort of demo app where I've been throwing in my latest experiments. So it's not too pretty, but works for me. So first thing, I'm going to look at the peers. We have some bridge nodes for Ethereum and making the Ethereum data available on IPFS. So these are Mustakala nodes that Herman has helped set up in various places around the world. So yeah, he's experimenting with the sort of the DevOps side of helping seed some of this information. So my goal here is to make a light client for Ethereum that works over IPFS and libp2p, and the main reason I want to do that is to make it work in the browser. The Ethereum network is mostly TCP UDP based, and so that's not something that I've been able to access directly from the browser, and so we're seeing if we can sort of create a secondary network and then bridge them. Here we need to first get a source of blocks of the latest block. And now you could do this in a more proper peer-to-peer fashion where you're downloading all the block headers and then determining which one's the best one and all this. And in the meantime, I've subbed that out with pulling it from Infura, which is a centralized service, and we're sort of like trusting that their blocks are good and what the latest block is good. And from there, we're able to look up a bunch of different information from the latest state of the blockchain. And so down here under query lookup, I've started coming up with my own sort of like query path specific to Ethereum, because if you sort of dissect it, we're going inside of Ethereum. We're looking at the latest block. Inside of that, we're looking at the state, and we're looking at the state of this particular address, the account at this address, and then its balance. Now, when you translate that into an IPLD path, it is this less legible thing. Here's the content ID of the latest block, and then we're going into its state. And then here is like the hash of the address chunked into half bytes, which is how the state tree is internally represented. And then we pull the balance off of the leaf, which stores the account. And so I can go ahead and perform that query. I can already tell my computer is struggling. It's also running out of battery. Thankfully, we're almost done with it.
You can try this at home anyways.
Yeah. There's a link in the chat. The query button did not seem to get started. There we go. So on the right, it's going to show its individual node lookups. I'm going to, I think one of the nodes timed out. I'm going to try restarting this, but also, as I mentioned before, my laptop does not like sharing the screen, and that might bring it down. So yeah, if you do want to try it on your own machine, you can click that link. Remember to start tracking the blocks. And then if you open up the debugger, you can see the sort of the progress of making the individual queries. Let's see if this one, yeah, it seems to be working. Okay, so here you can see we're starting to walk down the state tree. We started at the block, we're going down the first node of the state tree, and we're gonna go maybe 6 nodes deep. But yeah, I can tell already that it's performing a bit differently than it does normally. It's very slow to move from one block to the next.
It might be that the laptop right now is like trying to throttle like any resource consumption to make sure that the battery lasts longer. Chrome is like very expensive on the battery.
Your Mac will sleep soon.
Yeah, I just plugged it in, but I don't know if it's going to affect performance much. Okay, yeah, now it's kicking a little bit. So this is worked for me. It's definitely very slow, and if the more data that we start pulling off of it, it's going to continue to be slow. Okay, so we did get our first result here. So this is the balance of this account. And this is encoded in hex and measured in Wei, which is like 1/10 to the 18 of an ether. So that this is like the smallest decimal unit. But we could grab that, and if you divide, oops. Convert that into ether. This person has near 7,000 ether, so some miner or something. And then the sort of my latest work was getting the EVM, the Ethereum virtual machine, to run based on these IPFS lookups. So this one is it makes many of these query lookups, and so maybe quite slow, and maybe it won't finish, but we can see what happens. So what we're doing here is someone's created this this token called Gnosis. So the whole idea behind Ethereum is that it's a platform for building other things, and so to help run their system, which is a prediction market, which is a topic for another time. They've created this token, and this token works as a contract on top of Ethereum, and it records the balances of people and keeps track, lets you send it to other people. And so here we're sort of sending a call into the Ethereum virtual machine, asking it what its the balance of this account is. And in order to do that, it's going to load the code of the contract and then lazily look up the storage of the contract. And so when you press that button, it runs the virtual machine. It takes maybe 20 seconds to process the request. All these things, while they've showed that they work, they would be greatly improved by being able to make the full query, the full path, over a new version of BitSwap. So may be turning to my effort to helping realize that goal. Okay, I think I'm going to call this demo before my computer gets started.
Kumavis, you started breaking up, and I wonder if you're not breaking up now that you've stopped sharing. Oh, maybe.
Yeah.
Am I breaking up for everyone, or is it just Kumavis's connection?
No, just Kumavis. And I'm getting an echo from him.
All right, well, Herman has also been involved in this, so maybe we can still try to do some Q&A. Do people have any questions about this demo? Well, I'm curious.
The chat that,
one at a time, please.
Yeah. Just gotta go first. Stephen has been saying in the chat that given that Go IPFS does or will very soon support treating ETH nodes as IPLD, we could turn the G ETH daemon into a data store for IPLD nodes, and that would simplify querying data for anybody.
I can probably, like, if you want to go, Herman, like, I can also like chime in into this one. If you want to go first, go for it.
Well, one of the visions is the blockchain is already 200 gigabytes of weight. We believe that in 1 year it will be weighing like 3-4 terabytes. So one of the visions people at Ethereum has is to specialize nodes. You will have nodes for mining, nodes just for storage, nodes just for running transactions or relaying them, and the storage will be distributed somehow. So IPFS is the first option. A person will want to have a client, it will be very expensive for that person to have the full storage. So plugins to hook the storage into IPFS are on the go soon once we get this technology fast enough for clients to work on top of it. So that assertion is correct.
Awesome. Like the bit I was going to say is really with integration. So right now, the way that Kumavis did this demo was by getting just IPFS running on the server and attaching the parity implementation of Ethereum, so the REST implementation of Ethereum called parity, as a data store to just IPFS. So we use the same model that we have in Go IPFS, and like we have pluggable data stores. And right now, parity is like a read-only data store where, like, if someone searches for a CID that is from an Ethereum block, like it will get from the data store, and the data store is essentially requesting it to the parity client through an HTTP call, and like the parity client will get a block and give it to us. It's kind of like a bridge. It's really a bridge. We can do the same for Go IPFS today. You don't even need GET. The only reason why you use GET is if you want to bundle the GET code with the Go IPFS code and like just create one binary for both. But I think, as Herman was saying, I think like it will be more useful for people to have like this binary separated with a very clean interface, like this HTTP API seems to work well, and so that like any person can plug the data stores that they want to their nodes, and if they want to plug the Ethereum one independently, if it's from GET or Parity, they can, and they can ship their own version to their server, which then can have as much storage as they want to hold all of those blocks. But yeah, totally possible.
And now a very interesting part is if you have a lot of machines synchronizing and connected to IPFS, so some of the machines will start to store data, start and pin the nodes. So as much, the more machines we have, the more faster we will have the IPLD nodes available to the mesh.
And it's faster to sync.
Imagine the sync, it will be connect, boom, you're synced.
Awesome. Any further comments, questions on this? I don't see any hands raised. Or Kyle, are you raising your hand?
Oh, no, sorry.
Okay.
I'm making coffee over here.
All right. All right. Well, thank you for that demo. That's super exciting stuff. Is there any final stuff that you guys wanted to say, Kumavis or Herman, about that demo?
Well, we want to make this faster. For today, the bridge are centralized. So we need to download the whole blockchain on each of the nodes and start and wait for the nodes around them to synchronize to get the keys. That will be the real decentralization. We are looking forward to that this week or next week to have everything already indexed.
That's super cool. I am assuming that this is all open source. Can you post the links to the repos?
Yeah, everything is open source.
If you could post the link to the repo on the notes for this call, then people could like follow up.
Great, thank you very much. And then on to our next, oh, and could someone also add those links into the Hackpad, because the chat, remember, well, I guess anyone who's been using the chat, like the chat in Zoom goes away. It doesn't stick with the recording. So if you put stuff in there that you want to stay for the long term, make sure they go into the Hackpad as well. All right, on to our next demo from Saeed and Matt about IPWB, Interplanetary Wayback. Take it away.
Okay, well, I guess I'll get started on this. Let me do the screen sharing. All right, I don't know how to do the screen sharing on here. Oh, there it is, okay. We'll just do the whole desktop. Okay, so how do I hide this? All right, so what I'll be doing here is demoing IP Wayback from two clean machines. On the left machine, I have my local one. It's in downloads. It's not actually on here yet, as you can see. It doesn't exist. This one, neither of them have it. So this machine's actually a remote server here. So what I'm going to do is I'll just pull the source for the sake of simplicity, since I have some sample data there. All right, and I do have IPFS on here already, as you can see. So let me cd to that and then install it. And you can also pull this from PyPy as well, but I've got some sample data in the GitHub repo, so you should be able to use it that way as well. So all right, so from this, let me just show the directory. You can run a few different commands. The way that IP Wayback works is it's got an indexer that creates CDXJ files and a replay system that reads those. And you can do it in creating the CDXJ files. It stores the IPFS hashes in there that allow the content to be surfaced on replay. So as an example, I do IPWB index, and then I've got like a sample work here. It's called Froggy. You can see the output here. Oh, I might need to start the daemon. Maybe. Yeah, okay, so I gotta start the.
Can you increase the fonts as well?
Oh, yeah, I can do that. Let me just start the daemon. All right, and then pull this again. So you can see the output looks something like this. So it just has some metadata on top, and then for each of these cert URIs here, you can see there's associated IPFS hashes for this. This is representative of the HTTP header as extracted from the work, and this is the payload representative of this cert-based URI at this date time. And so the source is just, there's one HTML page, which I'll show you here. So anyway, you could copy this over, you can do it some other ways, but let me copy this over to this other machine here, which I don't currently have IP Wayback on, I believe. So I'll just install it via pip so you can see that it does do that. And I don't think the daemon is running, so let me throw it in the background. All right, and then I should be able to, so anyway, once you start, if you start the replay system, you can do this once the daemon's running. You can actually hit it at localhost. So you can see here. So we didn't actually pass it any CDXJ data, so it's not aware of that file yet, but it does have some sample data. So an example pulls from the sample data. You can see this page is pulled from IPFS, which is based on these hashes here. But from that one I did before, let me kill the replay system, and let me create that CDXJ file and paste it in here. So this is the, I think I got everything. Did I get everything?
Mm-hmm. Yeah.
Robots. Okay. Yeah. All right. So this is just a CDXJ file that. Are you sure? Oh yeah. So that's what it is. It's just a nano weirdness. So it's scrolled over there. All right. So now we have this CDXJ file that you can see there. If you run that to the replay system, we'll start that up, and we hit it again. You see there's 3 different ones here, and it has additional options to control the daemon and where that stuff that we're going to do. It also uses service worker on here to do the rerouting. So in Web Archives, if you go to replay the page, it'll reach out to the live web to try to grab the live web content if you don't rewrite the link. So one of the works that Suud actually did earlier this year was to implement a service worker to intercept these requests to live web and point them back to our replay system. So in this example, compared to the last one, you'll see it also separates it out so you can see the different. So if you want to see all the different resources that are in it, those are there as well. You can see. So this resource here is actually being pulled from the local replay system. And if you pull this up, where is it? You can see the service worker actually intercepted this thing. Let me see it. Yeah, let me redo this one. So you can see the service worker actually intercepted this request for this image. But if you look at the URI of it, it's in fact goes to the live web page. So this example kind of demonstrates of, based on a work file that we used, let me go back over to Python Skevin. From this source here on this remote machine, we indexed it, and you can actually just replay it. So I've got that same, the point is, you index on this machine, and once you have the index file, you should be able to replay that anywhere that can hit this IPFS node to do that. So if you've got fresh work contents, it essentially pushes these work files, these web archive files, into IPFS and strips out all the relevant content in the responses and allows you to serve those elsewhere. So if we were to just, let me pull the source on this one, I can show you that. Okay, so if so this is the same source, even though it wasn't so, as an example here, you can actually just pipe this locally into the replay system. And when I go back to here, this is an example where I had multiple URIs, the same thing, so you separate it out. And we have, if you were to just type in memento.us, the page archive there, it gives you a listing of all of them on there. We have Memento implemented in here, the actual Memento protocol. So if you were to hit this one here, there should be a time gate endpoint or a time map endpoint on here. So if you time map, I hope this works. It should just be, I think that's the routing. Okay, that's not the routing for it. But if you hit the actual memento itself, you should be able to see the endpoint. Come on. Okay, so maybe not. So I think it's on the memento itself. Anyway, we've got limited support for memento currently, and we're currently working on getting the rest of it on there to make it so we can associate these different captures based on the hashes that the CDXJs represent. So using a source like this, where you just have these SERP-based URIs, a date, time, and this additional metadata about it, you'll be able to dereference the web archive content from IPFS on there. So I think we've done a little bit of research and integrating this with IPLD, but it's not in terms of, so it can say a little more about that. In terms of retaining the old versions of it, I guess there's some issues currently that we're hoping to make more of an indexless system in the future. We don't have this format. So I'll let Suwood say a little bit more about it if you want. I can keep this up if you want. Go ahead and say something if you want.
You're going to turn your mic off?
I don't know how to.
Hello. So I will briefly describe what Matt just did. There is a thing in web archiving called WARC files, where you record each captures of web pages, all the request and response of HTTP records go there. It's like they're concatenated with some extra metadata around that. So with all the headers and payload and everything. So what we realized is every time you get a response from a server, the headers are different, but if it is the same page, there is chance that the content will be same. So with that in mind, what we did is we go through the records of WARC files that are saved when a page is captured using any crawlers. And we go through these records and separate out the headers and payload and put them in the IPFS system separately. And this happens at the indexing time. So we got like a WARC file. We'll go through each record one by one, split records header and body or payload into separate parts in the IPFS system, so that the payload, when it is the same, we get the benefit of deduplication basically. And we note down the IPFS hashes in an index file, and we note down there like what was the URL that belongs to that particular capture, what was the time when it was captured, and what is the header and payload hashes. So those are the things that go in the index file. We call it CDXJ file. So basically what Matt did, he created or used an existing WARC file, indexed it, so the content was pushed to the local IPFS system that was running on a remote machine. So the content lived there. We just copied the index from there on our local machine, and then we ran the replay system. And replay system only needs to know each URL's header and payload references in the IPFS system. Then it can query in the global IPFS system to find out where the content is. And actually, when he replayed, the content was not served from locally, because locally it didn't exist. It was being served from the previous machine where we indexed it. So
yeah. In previous demos, I've cut the network connection to show that it was being pulled from locally, but that's a little problematic here.
So that's it. Right now, it requires us to exchange that index file here and there. We really want to make it an indexless system, basically, and all the querying for the records and all the captures that we call mementos, basically, they need to exist inside the IPFS system itself. And IPLD and IPNS can come in handy to solve those issues. And I will share a link where we have some discussions around this mechanism that we have, like the new architecture of the system. When that so essentially what we need is IPNS right now does not support history basically. So the moment you change the IPNS record to a new hash, you lost the track of the previous record it was pointing to. And that's something that we want to keep an entire history of in order to make it happen. And then there will be, for querying mechanism and all, we need some help from the IPLD implementation so that there is the network graph of a relationship between nodes. When these two pieces are in place, and perhaps I think IPLD is mature enough for that purpose, but IPNS is not. So for that, IPNS need to be implementing some sort of blockchain mechanism or something to keep all the historical records, and then we can put the memento time maps and other memento protocol related stuff in place, and then it will be right now it is yet another replay system that stores data differently, but then it will be a whole new system that has no other, it will have very little to share with what other existing web archival replay systems have. This will be like a more remarkable model which does not require any index or anything. Anyone can participate in archiving the web, and anyone can put a replay system on top of that. Things will be like aggregatable and replayable more easily than. And someone was offended by the serverless thing. It can actually create a serverless archival system in that model, basically. not the serverless that these cloud providers advertise for their benefit. So I think that's it, and we would take any questions if anyone.
Anyone? I don't see any hands up. Anyone with questions? I suspect that David has questions.
Well, I kind of got the spoiler at the Web Archiving conference in London. I got to see it firsthand. So yeah, this is super exciting. It's super awesome work, and really excited about the things that you guys are doing with IPFS. And I do, we need to chat again and understand what are the next steps. I know that you are looking forward to have IPNS and have IPNS in a way that can be broadcasted in a more real-time way, and Viso, which is also in this call, or it was. Here you go.
Yeah, so I'm right here. So if I can say a couple of words on that. We have an implementation already.
Mm-hmm.
Okay, so it's sitting there in the PR, and basically there is one issue that we do need to resolve is that we don't have signed messages in PubSub right now. So this opens the denial of service vector attack. Okay, so that's something that we either need to resolve in, I think we need to resolve inside PubSub and support signed messages. Other than that, it's mostly code cosmetics. We're having a conversation with Stabal and about how to integrate it. But the code is pretty much ready.
So you are suggesting that the IPNS will soon be able to tell the whole history of change, like how it changed over time? Is that what you're trying to say?
Well, not quite. I mean, you can keep the history if you subscribe manually to the PubSub channel. But what we'll be able to do is that we'll be able to broadcast PubSub updates, IPNS updates, so that you don't have to. You're not stuck with stale records from the DHT, and you just get the fresher records from PubSub.
So basically, now that would be a responsibility of someone else to note that listen to that PubSub and record it somewhere in order to keep the history.
So the name system itself will do it.
Oh, okay. How about bringing in Ethereum in this picture, like writing a contract, like
well, honestly, the current implementation of PubSub is flat sub. So it's fine for first prototype or first implementation and small scale testing and everything. But it's quite inefficient in network in terms of network usage. So if we push so much data as could be coming from the Ethereum blockchain, this might be problematic. Although you can try it, I mean, it's just that it's likely that's not going to scale very nicely. So, but it's an experiment. Go ahead and try it.
Yeah, I mean, the good thing about putting it in blockchain would be then we'll be sure for the part that is cached locally, because in archival system, we need to list all the changes, like change history, we call it time maps basically. That is a very frequent request. We want to know all the captures all the time. And when it is in blockchain, you bring it locally and then you can query it as many times, and you won't be afraid that anything will be changed in the middle of something. Like, I mean, if you have history from like yesterday till like 5 years ago or something, you are sure nothing is going to be injected in the middle of it. If there is any new change, that will be after yesterday, right? So in PubSub, I don't know how that record will be replicated.
Well,
a couple of things. Yeah.
I'll jump in there, and also reminding that we have like 5 minutes left. That it's a confusion that comes up really, really often, especially around IPNS. That IPNS is not a data format for representing history or version history. It's just a technique for publishing hashes in a way that you can be confident about who published that hash as a pointer to another hash. So that's it. And there's only a current state of that IPNS hash. It's designed with that assumption. So if you want version history, you need to choose a data format for expressing that version history and express that version history on your side, the history of what were the hashes for that data. And one way you can do that is you can put that into, you could use a CRDT, a conflict-free replicated data type, to represent your version history. You could also use Git-style version graphs. There are lots of different ways to represent version histories where the values of each entry is just a hash. Mm-hmm. And then having created that data structure, you can add that to IPFS. You now have a hash for the current state of that version history graph that you can pass around. It's effectively like a Git commit hash. And so so all of that you can do without a blockchain. What the blockchain gets you is that you can assert publicly in a way that the entire network sees that assertion on a blockchain. So then you get that validation.
That's actually important from historical perspective, because otherwise, if it was someone's local history and they can, on demand, they can provide that or something, then they can change things after the fact. It is very critical in archival systems that if you said yesterday that this URL belongs to this particular hash, then this needs to be like a nail in stone. Like, you cannot change, like, no, I didn't say that yesterday, actually. No, you cannot. So that's where putting it in a public blockchain makes a lot of sense. You advertised your URL associated to a hash, and it was signed by you. It needs to be recorded and known and non-changeable by anyone. So that's very critical.
Yeah. I think there's like multiple layers here that we're talking about, and like everyone is talking from the perspective of on like the layer that they are building right now. Mm-hmm. And what I understand, like what, for example, the IPNS over PubSub enables for the interplanetary webback is something that we chatted over when we were at the conference in London, which is I know that like Matt has also an extension for Chrome that lets you create the archives on the fly on Chrome. Mm-hmm. So you can start archiving pages as you go, and like only instead of like crawling the web pages, like you can just capture the pages that you are seeing, and you can have like these shared archives with other people that you keep like publishing, saying, okay, I archive these pages and X person archive other pages, and now you can have like the work file being created collaboratively, right? Like, and you can broadcast these updates over PubSub, like make sure that like they're assigned, so like no one is like spamming, like saying that they have archived something and they didn't. So it's good to have the signatures there. And then it's also important to have some organization, some entity backing up these archives, right? And this is where like a library could follow these feeds when like archive it themselves, or we could have a smart contract that is following these feeds, and like basically the smart contract, right, it does like, it just follows, and like each time there is a new work file created, it pins it to somewhere. And again, this is just like a tool, a mechanism for an institution that is responsible to archiving these work files to follow these feeds. I think the special thing here, since we have Kumavi's demo and now your demo, is like if we get that smart contract, then you can go all the way around, right? Because now you can go from the smart contract and like just traverse the graph using what Kumavi's shown, and like you can go back to the archive file that you created on top of IPFS, and just like with a IPLV like path where you say, okay, I want this website that is referenced by this smart contract, and I want the version that was captured on like this date or something. And just like with one path, you have like access to the entire version history that has been captured and preserved through this mechanism, through all these pieces. So yeah, let's bring all this, as Matt pointed out, like we have like 1 minute now. Let's bring all of this to like a note. I would suggest for us to open an issue on IPFS/notes. If people like, I don't know if you have a special repo for discussion of ideas for interplanetary webback, but like, yeah, like if you have a special repo, let's use that. If not, let's use press notes so that everyone could like chime in with these ideas and perspectives and building blocks. Sounds good?
All right. All right.
Yeah, awesome. Awesome.
Thank you. I was just searching. I feel like there was already an IPWB issue somewhere. It's not an IPFS notes, but let's go ahead and create another one in IPFS notes. All right, we're right at time. Does anyone have anything final they need to call out before we end this call? All right, well, thank you to our presenters. Those were both really exciting. I've been looking forward to them for a long time.
Yeah, thank you.
Yeah, thanks a lot.
Super cool.
Herman, did you have something? Oh, okay.
No, thank you very much.
Okay. Thank you, everyone. Have a great week.
Bye-bye.
Bye.
That when you finish the